Have you ever wondered how your favorite shopping site can handle a massive Black Friday sale without crashing, or how your bank's app just never seems to go down? Well, the secret sauce behind that is something called database clustering. It's the tech that takes a system from fragile and prone to failure to something incredibly indestructible. So let's break down how it all works.
To really get why this is so important, let's start with a pretty scary question. What if the very heart of your business, the thing that handles every order, every click, every single piece of data, what if it just stopped?
I want you to picture it. It's the biggest shopping day of the year. Thousands of people are hitting your site, credit cards in hand, and then, poof, your one and only database server gives up the ghost. Everything grinds to a halt. No orders, no angry customers, nothing. That right there, that's the nightmare scenario that clustering was born to prevent.
So, how in the world do you prevent that kind of catastrophic failure? Well, the answer is to stop thinking about a single point of failure and start thinking about a web of strength. It's called a cluster, and it's the key to making your system resilient. Okay, so what is a database cluster really? Simply put, it's a team of database servers that all work together so seamlessly they act like one single superpowered machine. So instead of putting all your eggs in one basket, you spread the load and the risk across the whole team.
Here's a perfect way to think about it. A single server is like a busy supermarket with only one cashier open. If their scanner breaks or they need to take a break, the whole store grinds to a halt. Total chaos, right? A cluster, on the other hand, is like opening up all the checkout lanes. If one cashier has an issue, no big deal. The other cashiers just keep the lines moving. It's a beautifully simple and powerful idea.
Now, you should know there are a few different flavors of clusters out there. But for today, we're going to zero in on the one that's absolutely crucial for modern apps: high availability clustering. The entire name of the game here is to make sure the system is always on, because every server in the group is ready to act as a backup for every other one.
So, what's the big payoff here? Why go to all this trouble? Well, it turns out there are 4 huge wins that make clustering the absolute gold standard for any application that just cannot afford to go down.
First and foremost, you get fault tolerance. Look, hardware fails. It's not a matter of if, it's a matter of when. With a cluster, when one server inevitably goes offline, maybe a hard drive dies or whatever, another one just instantly picks up the slack. A lot of the time it happens so fast your users don't even have a clue anything went wrong.
The second big win is scalability. So your app is a huge hit and your user base is exploding. Instead of having to buy one single, gigantic, and wildly expensive new server to handle the load, you can just add another, more affordable server to the team. It's a much smarter, more flexible way to grow. Second big win is scalability. Third, you get a massive performance boost. I mean, it just makes sense, right? You now have a whole bunch of machines with their own processors and memory all working together. You can spread all the user requests across all of them, which means everything feels way faster for your users. And finally, number 4 is global reach. This is really cool. You can physically place the servers in your cluster in different parts of the world. So a user in London hits a server in Europe, while a user in Los Angeles hits one in North America. This simple trick dramatically cuts down on lag and makes your app feel snappy for everyone, everywhere. And finally, all right, so we get why clustering is so powerful. But what about the how? How are these things actually put together? Well, it turns out there's more than one way to do it. Let's take a look at the 3 most common blueprints for building this kind of resilience. First up, we have what's called active-passive, or sometimes master standby. The airline pilot analogy here is absolutely perfect. You have one active server, the captain, that's handling all the work. And right next to it, you have a passive server, the first officer, that's just idling, getting all the same updates, and is totally ready to take the controls the instant the captain has a problem. Next, you've got active-active, or multi-master. In this model, every single server in the cluster is online and working all the time. Think of it like a customer service team where every single agent can handle any type of request that comes in. It's all hands on deck. This gives you incredible performance. But yeah, it's also a bit more complicated to manage. And finally, we have what's probably the most popular setup out there, known as master-slave, or more commonly these days, primary replica. Here's the deal. One primary server handles all the data changes, what we call the writes. Then you have a bunch of replica servers that just make copies of that data and handle all the read requests. The news organization analogy is spot on. One editor approves the article, but then dozens of websites can show it to millions of readers. So what's happening behind the scenes to make all this magic work?
Well, you can think of it as a constant four-step dance. First, data replication is always happening. Data is constantly being copied between servers so they're all in sync. At the same time, every server is sending out a tiny heartbeat signal to let the others know it's healthy. Now, if one server's heartbeat suddenly stops, that triggers step 3, an automatic failover, where a standby server is instantly promoted to take its place. And who's directing all this traffic? That's the load balancer. It's like a smart traffic cop, sending every user request to the best server for the job. It's this whole seamless process that creates the illusion of one single unbreakable system.
Okay, this all sounds pretty amazing, and it is. But we have to be realistic. Clustering is a sophisticated solution, and it is not a magic bullet. It comes with its own set of very real challenges.
You really have to keep 4 big trade-offs in mind. First, it's complex. Setting up and managing a cluster correctly takes serious expertise. Second, data consistency. Making sure every copy of your data on every machine is perfectly in sync, down to the millisecond, is a really hard engineering problem. Third, cost. It's simple math. More servers means more money for hardware and licenses. And finally, you are completely at the mercy of your network. Your cluster is only as strong as the network that connects it all together.
But here's the bottom line, and this is the most important takeaway. For any application that is truly critical to a business, e-commerce, finance, logistics, you name it, the cost of being down, even for just a few minutes, in terms of lost revenue and customer trust, almost always far, far outweighs the cost of building a resilient cluster in the first place.
So when it all comes down to it, database clustering is about making a fundamental choice. It's the choice to proactively design for resilience instead of just crossing your fingers and hoping for the best. And that leaves us with one final question to think about. Is the technology that you rely on every single day built on a single point of failure, or was it truly built to last?